Okay, I've kind of lost track of when I had the camera on and when I didn't, because this is so exciting. And the thing I just told you guys, I actually saw a flicker of interest. Here's the big deal. I'm sure we did that. Okay, that for what value is torque over net force equal to 0? And set that equal to 0, you get x bar equals this. Okay, well, since the net torque or net force is not 0, then if this is 0, okay, then the torque has to be 0, right? Since F net isn't. Okay, so that's the position about which we can rotate this and get 0 torque. Wait a minute. I want to make that same connection. I will. If you got no torque, how much work does it take to rotate it? There's no, so the potential energy isn't going to change, right? Simple explanation why the potential energy doesn't change. More complicated explanation is the total mass times distance of that the masses on this side increase is equal to total mass times distance that the masses on this side decrease. Okay? If you're at the center of mass, it's real easy to rotate the thing. You don't have to do any work. Of course, in the real world, you have to overcome a little friction. Okay, anyhow. Okay, so we've got this. And then we call this value of x bar the center of mass, which is just the sum of your mi xi's, which is just what I wrote down here. But in general, you could have many masses, right? Over the sum of your masses. Now, that leads directly to the integral of density times x with respect to x, which is your total torque. If you got an infinite number of masses, mass distribution. And down here, the total mass. Okay. Formulas that you saw in Calculus 1 and learned how to use and should maybe review with a little greater understanding. Then the torque about any point is the same as if all the mass was concentrated at the center of mass. Now everybody in here has had statics and used this, okay? But this is the reason. And I'll add one more little thing. If you want the moment of inertia, you just add up all the mi xi squareds, right? Because that's your mr squared, okay? So you'd integrate rho times x squared. And you would have done that in calculus. It would be in your calculus book, whether you did it or not. I kind of think you probably did it. But you didn't know what moment of inertia was, so you just did the stupid thing, okay? Now you know.